back there.
I like that chair.
Yeah, Susan who works had some.
I would fall out of it if I tried to sit in it, but I still like that chair.
So this is what you see here. We have some plastic models of what we did recently.
Wow.
These are models of space hardware. Essentially, we have this housing here, which is all sealed to a very high vacuum. Inside, this is a model of half of it. Inside you see a cube made of 6 walls. Inside this cube is the heart of the system, which is a solid cube of gold platinum alloy. That is very accurate. The cube itself, this outer cube, has to be very accurate. And by accuracy, I mean parallel and perpendicular in all directions. There are 2 of them on both sides of the
And what
chassis.
what does this thing do?
This is the heart of a drag-free satellite, which is part of a system that, at the ultimate, is meant to measure gravity waves.
Gravity waves.
Yes, and the idea is to put 3 satellites on a constellation far away from Earth, so they're not affected by any pollution from Earth, particles, radiation, whatnot.
Yeah, we tend to pollute things, don't we?
Oh yeah, big time.
How far out will these things be going?
This will be following Earth in its orbit about 20 degrees behind. So it's very far. The satellites will be in a constellation, as I said, 5 million kilometers on the side. There'll be a triangle. So there will be 5 million kilometers between them. And they will send laser beams between all 3. And by these laser beams and measuring interferometry, the idea is to be able to detect changes in the distance down to nanometers. And when a gravity wave goes by, hopefully we can measure the amplitude and frequency of this wave. And since the frequency is expected to be in the millihertz range, meaning it takes thousands of seconds for one cycle, that means that the satellites have to sit very, very accurately interplaced down to nanometers for this long time, hours.
And you achieve that by
building them drag-free.
Drag-free.
Drag-free. Because we all know that the space is empty. It is not. We always have molecules, we have particles running around, and each molecule that hits the spacecraft knocks it a bit out of its normal orbit. So the idea is to have a body inside the satellite, and this is the idea of the drag-free satellite. There is a floating body, floating mass inside the satellite. And this mass does not see any of the outside molecules. Therefore, this mass is in a real orbit. And by keeping the satellites very close around this little mass inside, by detecting where the mass is in the satellite, and again, we are talking nanometers, and we keep correcting the position of the satellite, and we measure from this little mass, not from the satellite, we can achieve this stable orbit of the whole thing.
And you use gyros to stabilize and keep your position?
We use gyros, we use micro thrusters, a lot of devices on the satellite to keep it.
Well, thank you for your time. Is
You're
this your dog here?
No, that's not my dog.
Not your dog?
My dog doesn't bite.
Your
This
dog
is not
doesn't
my
bite?
dog. No, this is one of the employees.
Very cute dogs.
There are two of them. There are two of them, yes. A boy and a girl.
Well, thank you very much for your time.
My pleasure.